Hello there, how's it going? If you're working with Flink, I might have something for you. Yeah. So I've been working on streaming, stream processing a couple of times now, and I've really experimented and explored a couple of different stream processing tools and technologies, Kafka streams, KSQLDB, Apache stream, injection, stream injection, Hoodie streaming injection, Flink. But now I think I've done a couple of work with Flink before, and now I'm trying to do more. I'm trying to do a lot of like high level streaming, some complex streaming processing that we're trying to work on. And so let me give you the backstory, right? It's the last time I worked with Flink was more on AWS EMR, and I have the EMR here infrastructure. So like I have my own setup of EMR here. If you look at big data, so I have the AWS EMR, and I have Flink as part of the applications deployed. And if I have a couple of everything is in Terraform, right? And I have this modules here. I have the assembly where I have the EMR configuration. So the basic thing is for me to kind of run different Flink jobs, I have to kind of create another Terraform, the script. The script is a bit messy. If imagine I have like maybe hundreds or fifties of Flink jobs that I need to run, this is going to be a lot of messy. And apart from that is I really have to kind of get the CI/CD right, and how am I going to release this to production. All of those management complexity is really a challenge for me. And plus the expense, EMR is a bit expensive, right? So now the backstory, I was kind of figured out how I can run, EMR, successfully and scale up, in a scalable way. And I stumbled upon this, a Medium post by Airbnb, how they've really run, Flink successfully on Kubernetes. And I mean, yes, on AWS, for the resource manager, a couple of the Flink components, this is the Flink architecture, right? You have a couple of the components, the job manager, the task manager, and the resource manager, and the dispatcher. So they actually using the YAN as the resource manager. And some of the challenges that they run into when they're using the YAN for the resource manager. So I read about the article and I can relate, because with AWS EMR as well, on EMR, you really have almost similar thing. You have to use a YAN cluster. So I felt like, I can understand. So that gets me to the Kubernetes setup. So this is the architecture of Flink itself as a separate application. And there's another architecture as well, which is for the Flink on Kubernetes. If you're running Flink on Kubernetes, this is the architecture for it. How the Kubernetes API server run as a resource manager for your application, and how you bundle everything together for the deployment, which really controls the job manager and the task manager, and how do you allocate slot for your application and all of those auto scaling and all of that, running on Kubernetes as the resource manager and the scheduler. Yeah, so you can go through the documentation if you want. So this is really the backstory of the architecture, how the components works together and all of that. So I have my own setup as well, which really runs on Flux CD as my GitOps implementation. So what I did was I have all of my applications that I run on Kubernetes here. And on the Flink side of things, I have the Flink operator, which I actually deploy with Helm chart. So I have the Helm repo, and kind of, deploy the Helm repo and then the Helm values. This is my Helm value for, installing it. I have it in HA, so I have the Flink, and I'm using operator 1.9.0, which is kind of the latest right now. So I'm also creating my Flink applications. I separate it to another namespace, so which is the Flink jobs. And so this is the Flink operator deployment. But the really key thing for me is how the operator really runs, and some of the challenges that I faced when setting it up on Kubernetes. There's a basic task slot, the task manager slot. You might really not care about this much, really, actually, but the most important thing is the state. I mean, if you're running a stateful workload, the most important thing for you is how do you manage your state, and how do you manage your checkpoints, save points, and where do you do that for reliability. You may want to change your cluster. How do you get your workloads back, and all of those setup is really the key thing. And how do you collect your metrics? Then, so Flink has a couple of metric exposition formats for Prometheus, Datadog, and all of that. So I'm personally setting up for Prometheus. So I have a Prometheus factory class that I set up to kind of collect the metrics to Prometheus. And if you look at my Prometheus URL here, I have my Prometheus here. If you search for Flink with it, so If you search for Flink, you see all of the metrics exported by Flink. So I have a I have a service pod monitor to kind of scrape the metrics exposed by Flink operator to Prometheus. So, but the most important part I want to show you is the job side of the deployment. So Flink has this deployment CRD, which is what you use to run your Flink application Kubernetes. And this is where you specify most of your configurations, like how do you manage your state, what state backend do you want to use. So before I go into that, I have my jobs already right on Kubernetes, and the job I have these two jobs, the word count and the state machine. So Flink has these components, and yeah, these components, which is the job manager and the task manager. How do all of these things communicate? They use gRPC, which is mostly like this Apache gRPC in Java. So that's what the components use to communicate, because you need to set up some checkpoints. And what checkpoint means is when you're running a stateful application, they need to persist the state of the operator you're using in your like operation processing topology, operator for windowing, aggregation, all of that. You need to persist the state. So the task manager needs to get the states and then pass it down to the job manager. But job manager is the one that controls the task manager. So but this is where you do the configuration for how you manage the state in the Flink deployment. So and if you want to manage the auto scaling of the job as well. And if you want to allocate some resources to your job manager, the task you want to run. For me in line 27, I'm running concurrently like 10 tasks. So this is where I run the task, and the parallelism of my task slots, I cannot use 4. Then my state backend as well. Flink has different options for state backend. If you go from documentation here, you'll see different options: the RocksDB, the embedded, and the file system. But to my experimentation and what I've read so far, I think RocksDB really have a balance between low latency and throughput, because it's embedded, but you can also manage in the memory allocation of how you use the RocksDB. So for me, I'm using, but you can use different state backend for different application. That's really what I want to show on this side. Is for this state machine example, I'm using RocksDB, and for the word count example, I'm using HashMap. So you can have different Flink application and use different backend depending on the latency and how large your state is going to be eventually. And then for the high availability as well, is using S3. So the key challenge for me when I was setting this up to use S3 for my checkpoint and save point is the access. So I don't want to really use the access key and the secret key. I want to use IAM role for service account, and I've tried different options. If you look at my README here, I've tried different options to use web identity token in factory class. It just doesn't work. So I had to, and I spent a lot of time on that to really use S3 as my checkpoint, for the state persistence. So I just tried, let me try the native access key and the secret key, and that's what eventually works for me. So I was like, okay, maybe it's a bug or something for now. I don't know. So, but this is the key thing. You supposed to actually have incremental checkpointing, because you don't want to take your checkpoints at once. That's going to really affect your workload and the performance of your stream processing. So it's good to have an incremental checkpointing. And so the way this actually incremental checkpointing works behind the scene is small about the Lamport, distributed algorithm. So it's kind of an algorithm we use to do asynchronous checkpointing. What Flink also has a way it does that in a way asynchronous way, whereby you don't really block your processing when you're doing storing the state. Yeah, you can see the state machine application and the word count application. So they have their checkpoints here and all of their HA configuration already here. So each of Flink deployment has a web UI. So each of your applications have a web UI where you can see what's going on. So for my application, I have an NGS proxy already, NGS controller on the Kubernetes, and this is the web UI for the word count. You can see the completed jobs and the running jobs in the web UI. So this is already completed. You can do the task manager and the job manager. So the job manager keep running. You can check the logs of the job manager from the web UI and the configuration and the metrics exported. So for the state machine as well, you have it here for the web UI for that as well. So basically, it's still the same NGS controller in the cluster, just like a path-based routing that you're using. So the task manager is still running because it's like a continuous running job. And the job manager is still there as well. So you have a job manager and you have the task manager for each of your application, and the parallelism of how many slots you want to allocate to the task and all of that. So it's pretty amazing for me, because the benefit is, this is the GitOps. I can add more jobs as I want, like state machine and word count. I mean, and another thing to note pointing is the how you package your application already building in Java, within the Stream API. So, for your streaming application itself, this is the infrastructure side of things. So once you get myself now, what I'm trying to do is once I get my infrastructure set up, it's really easy for me to focus on application development because Flink offers, so now I'm using the in and then the Flink API. So once the infrastructure is already set up, the way you focus more on your stream processing application development. So Flink offers different APIs. The Flink SQL, if you're running some SQL queries on your incoming stream, some different connectors you have. And if you're running the table API. But for me, on the application I'm currently working on, I'm using the data stream API to run my applications. I'm using Java. And yeah, I mean, that's it, yeah. Anything else? Yeah, the state backend, if you want to read more about the state backend options, the state type you have, the keyed state, and then the operator state, when to use what, and then the state options you have, and the file system you can use. All of this, you can check them, right? So let me know what you think about Flink, and how have you used Flink.